Hello and a very warm welcome to this session on machine learning and Power BI. My name's Alex Whittles. I'm a principal consultant at Purple Frog Systems and Power BI Sentinel. A little bit about me before we start. I'm on the organising committee for SQL Bits. I have a master's degree in business intelligence, a large section of which was focused around machine learning. I am principal consultant and owner at Purple Frog, which is a Microsoft data analytics consultancy based in the UK with a global client base, focusing on all aspects of data warehousing, cubes, ETL, reporting systems, machine learning, etc. And I'm also a data platform MVP. At Purple Frog, we also run a system called Power BI Sentinel, which is it's a tool that gives you enhanced disaster recovery, auditing and governance over your Power BI estate. So if you're using Power BI in any great extent, then you should be looking at this tool to help you with management of it. When I'm not doing that, I'm also a qualified pilot, so you'll find me at 5,000 feet up there somewhere. Right, that's enough of the intro. What are we talking about today? Two of the biggest growth areas in data at the moment are both machine learning and Power BI. And so this session is really about combining the two together. If you're a Power BI developer, how can you access the machine learning functionality? How can you use this as part of your day-to-day Power BI report process? What tools are available to you? How do you go about getting them? How do you use them? What do they look like? What's the benefits, pros and cons of each of them, etc. So this is one of the last slides you'll see. It's entirely demo based after this, and it's a relatively fast-paced run through all these different technologies. So yeah, hope you can keep up. We're going to start out with Power BI itself as a development tool. What can you do inside Power BI to help you with analysing your data better? Now, all of the demos we'll see in today's session use two different data sets. They're very, very simple dummy data sets that I've created. One is a set of tweets. In fact, if we have a look at the data, you can see that it's just 17 different tweets. We'll use this for a bit of text analysis later on with the Twitterer and the text of the tweet, etc. And then we also have a dataset table of vehicles. Now this is a load of metrics about a vehicle, obviously the model name, but the metrics about the performance of it, the engine size, the cylinders, displacement, horsepower, weight, acceleration, etc., year of manufacture, where it came from, the country code, and the resulting miles per gallon, the fuel efficiency of that vehicle. And we'll use this just to visualize good and bad vehicles, etc. So all of the demos we're going to be looking at use these two data sets. Okay, so let's start out with what do we have available to us out of the box with visuals. Well, one of the great new visuals made available to us over the last 12 months has been the key influencer, this visual here. So let's turn that on, and this allows us to look at a data set, and it identifies which are the most important or influential features, or which fields influence other fields the most. So what I'm going to do here is I'm going to analyze the MPG, the fuel efficiency, the miles per gallon. And we want to look at poor performing vehicles. So what influences the MPG to decrease? Well, we need to tell it which of the other columns we want to use in this analysis. So I'm going to pick most of them: acceleration, country, cylinders, displacement, horsepower, weight and year. I'm not going to include the model because that's a text field. We're not going to be doing text or semantic analysis yet. That comes in a little bit later on. I'm also not including this high MPG. That's a simple Boolean, true, false, good, bad, in this case high or low, which is a direct function of MPG. So they're going to have a very, very close link. Therefore, I'm not going to use high MPG to analyze MPG. That wouldn't make any sense. I'm going to use all the other columns to see how they influence this. So straight away, this has built a model for us, and it gives us the relative influence of each of these different attributes on the MPG. So if the acceleration is 11.2 or less, then it has a very strong influence in the MPG being low. The next highest influencer is country code. Country code 1 being USA, they're known for their gas guzzling vehicles. So again, that's a big influencer. Then reasonable step down, we have weight. As the weight goes up, the MPG goes down. Then the year, horsepower, the displacement, the actual size of the engine has a very small impact compared to the other features, and the same with the number of cylinders. So actually the size of the engine isn't really the factor here. It's where it was made and the acceleration and the weight. When we click on one of these, we also see a bit of a breakdown of it tries to categorize some of these values, in this case acceleration, as to the key bands that may influence. If we look at again country code, we can see 1, 2 and 3. If we look at the weight, it actually draws a scatter plot and gives us the line of best fit, so we can see the correlation between them. So it's a way of exploring the relative influence and of different attributes and how one affects the other. We can obviously change that to show how the MPG increases, and it's almost the inverse. This also lets us look at segments. So it clusters our data into groups of vehicles that exhibit similar features and performance. And it groups them together. So if we click on segment 1, for example, it'll define this as more than 5 cylinders, more than 139 horsepower, and the year is less than or equal to 74. And these vehicles tend to exhibit similar patterns of behavior. So you can use this to isolate different groups of your customers, products, etc., to be able to deal with them differently from a marketing perspective, etc. So what we've got here, this isn't a prediction model. This isn't trying to predict what the MPG is going to be. It's just running statistical analysis over all of the different fields to understand how they relate to each other. And fundamentally, that's what machine learning is all about. It's running lots and lots and lots of mathematical statistical models over data to build mathematical patterns of behavior between them. We can then take this one step further and use those patterns to actually start predicting, but we'll get to that later on. Another visual we have at our disposal is the decomposition tree. Now this is very, very similar to the key influencers, but it's a more visually interactive chart. So let's have a look here. Let's analyze the MPG, and again let's bring on the acceleration, country, cylinders, displacement, all of the fields that we were using before. So I'm going to say let's get the average MPG here. So the average MPG is 23.51. Let's break this down. Let's try and divide this now amongst different criteria, different models or cylinders or values of displacement, etc. But what is the highest impact field that we should be choosing to break this down by? We have to go through and choose all of these different fields, exploring the data. Well, what this decomposition tree does is it allows you to drill down directly to any of the fields that we've given it, but also it allows us to break it down by the high or low value. So which fields have the lowest MPG, and this will decide, using a similar process to the key influencers, which is the best field for us to break it down by to see the low values of MPG. So we can see horsepower is the key one here. So we can see as the horsepower changes, we can see how the MPG affects from that. And then we can go through again to see the next level, acceleration. And let's go through to the next level. And it will guide us through, advising us on which of these fields are going to give us the most relevant information on the next level down. One of the new visuals that, or the newest visual in this set of machine learning features in Power BI is called a smart narrative. Now at the moment that's still in preview, so you do need to turn on the visual at the moment. This is based as of November 2020. So if we go to preview features, you've got the smart narrative visual. If you turn that on, then you'll be able to see the new visual. So what I've got here is the same data set, but I've put a few visuals on here. This is the year, 70 to 82, the average MPG. Here we've got the horsepower versus MPG, the top 10 models in terms of their performance, their MPG, and then the number of cylinders with their MPG. So we've got this new smart narrative visual here. If we drop that on the canvas, this is going to create us some text. And this text is, it determines what that text is going to be based on the data within our data set. So at 34.67 miles per gallon, 1980 had the highest MPG and was 102.73% higher than 1973, which had the lowest. So it's identified some key things, some features, something interesting about our data, and it's presented here. As we then filter this to just 6 cylinders, it'll update this text to just reflect the data that we've got within our filter and give us something interesting based on that. Now that's useful, that's interesting, but I want to now edit this. I want to build up the text here, so it's not just telling me what I can see. I want to build up my own analysis. So when I click on this visual, I can review the details. I haven't got any custom values here, so I'm going to add one. So I can ask it a question. Which model has the highest MPG? And it comes out with Mazda GLC. I'm going to call this best car. And that then puts a placeholder variable in there, and I can then write some text around it. Has the best MPG of all vehicles. And I can then add another one. Which model has the lowest MPG? And I can call this worst car. So I can build up this this text block with any criteria, calculations, free text that I want, and then whatever I select within my filters, it automatically updates to rewrite all of this narrative based on the filters that I've applied. So there's a number of things going on here. First of all, we saw when I added a new value, this was using the same functionality as the Q&A. I could actually add a Q&A panel here and say here, which model has the lowest MPG? And it comes out and tells me. So this is the Q&A functionality. In fact, I can convert that into a standard visual if I want, and that just places a card here, which again will update as I interact. This Q&A was okay for creating a single visual, but you can't really blend it in with the context of further descriptions and text. So what Microsoft have done is taken the concept of that Q&A, allow you to define a question and embed it into the text of this this smart narrative. Really, really nice feature. I'm a big fan of this. The one limitation of this that I will point out is it does rely on the Q&A. And at the moment, Q&A is a little hit and miss. Sometimes it works perfectly. Sometimes it doesn't. Last time I did this demo, it seemed to work fine for which model has the lowest MPG, but it wouldn't work for which has the highest MPG. It just didn't give an answer. So it can be a little temperamental. Is it ready to go into full production at the moment, as of 2020? I'm not entirely sure. but I love where it's going, and it's improving all the time. So it won't be long before this will be unleashable on the world to be quite a powerful feature in your reporting. Okay, so these are the built-in visuals. There's also a host of third-party visuals that you can use within Power BI. So let's have a look at one of those. I'm going to click on Get More Visuals. And within here we have the Advanced Analytics section. And there's quite a lot of ML features, ARIMA forecasting, etc. I'm just going to search for cluster, and we have, let's try this one, the clustering using optics by Mac Software. Once we have that visual, so now we can drop this new visual onto our canvas. I'm going to use the same MPG dataset as before. I'm going to drop the MPG onto the Y-axis. I'm going to drop a composite of displacement and weight onto our X-axis. Both of these set to don't summarize. And we get a, there we go, all of our data points are plotted on the chart, and it doesn't just plot them, but it identifies clusters or groups. We saw on the key visuals visual where it identified different groups of vehicles based on all of the criteria we'd specified. This is doing a similar thing, but just based on displacement and weight and their function to MPG. And it's identified that they all form part of one cluster, this blue highlighted area. Apart from one vehicle that stands out up at the top that is clearly not a part of that cluster. So if we hover over it, we can't see the details. So let's just drag on the model onto the tooltip. And that's now going to allow us to see what that model is. And we can see that it's a Mazda GLC. So what does this do to us? This tells us that either that's an exceptional vehicle that has an MPG fuel efficiency that is so dramatically better than any other vehicle that we should look at that as a model going forward for all the vehicles we want to create. Or more likely, this is dirty data. I know in fact it is dirty data because I edited that value earlier to make it stand out. So this is very useful for understanding where data's coming into your company that isn't valid. Erroneous sales or corrupt input files that have come from third parties, invalid calculations in Excel, things like that. Running it through an outlier detection like this can give you a very quick view of whether your data is consistent or whether there are particular problems. Looking at things like fraud analysis, do transactions stand out? This is a simplified version of that. And you can use it to, or tools like this, to either remove, correct or clean your data before then doing further analysis on it, whether that be just normal reporting or further machine learning. And there's loads of other third-party visuals in there that you can play with. They all have their own different functionality and style, but it's very easy to access. So everything we've looked at so far has been focused around the visuals side of it. How can we display our data to use ML to gain greater insight into our data? What about actually using ML to prepare our data, to be a part of our Power Query or M code to enhance our ability to actually understand the information? Let's flip over to a different data set. Let's instead now look at our tweets. So if we wanted to, for example, do some analysis over our list of tweets, what can we do? Well, at the moment, all we can really do is count the number of tweets. We can't really do anything, get any insight over them. How do we know which are good or bad tweets? Here we only have 17, but what if there were thousands or tens of thousands of messages? When we pull in feedback for things like the SQL Bits conference, we get thousands and thousands and thousands of amazing feedback, written feedback from our attendees. Some with helpful advice, some with positives, some negatives. We need to understand that, be able to filter them down and say, right, let's look at the ones that are either really, really good or really bad, so we can focus our attention on the priorities, where we need to put our attention. How do we do that without manually scanning through thousands of tweets? Well, machine learning can help us with that. Let's go into Power Query. So what can we do to analyze this tweet text? Well, up on the top right, we have our AI Insights panel. And this is where we can do some, for example, text analysis of our data. So let's do that. Now, to do this, you do need a Power BI Premium facility. Now, that can be Power BI Premium, or it can be Power BI Premium per user. So this is now looking at my Power BI tenant and determining, do I have Power BI Premium? If I do have Premium, then which Premium facility, which service do I want to use, and what functions are available? So these are all built-in functions within Power BI that we can just consume without having to do any work on them. So there's a few things we've got here. First of all, it gives us a list of all of our premium capacities on the bottom left, and we can drop that down and change that if we wanted to. And then this has given us three options: language detection, key phrase extraction, and score sentiment. Detect language does what it says on the tin. It'll look at a bit of text and return back, is it French, German, Italian, English, etc. Extract key phrases looks at text and identifies common groups or key phrases of text that are common to the whole pattern. So that may be great sessions, or it may be the room was too cold, or things like that. Rather than looking at each individual word independently, it's the context of a phrase that's really important. So by extracting these phrases, you can start to simplify the analysis of text. And then score sentiment is the one we'll be using here, where it looks at text and determines whether it's positive or negative. Is it good or bad? And that's not a Boolean. It's not a good or bad. It's a graded from 0 to 1. 0 being bad, 1 being good. And it's anything in between. So let's say we're going to use a column name for our text, and we want to use the tweet. Now, if we knew the language, we could put the language ISO code in here. It will detect it automatically. We could run a language detection first and then feed that into this parameter. We don't need to in this case. So this is now running that analysis on every single column, on every single row rather, in our data set, and it'll give us a column of sentiment. And there we go. One thing to watch out for is that most machine learning functionality returns back as text. We want to change that into decimal number just to make the analysis better. You'll need to do this for pretty much any ML function you bring in. So what does that do for us? Well, let's close and apply that value. One of the things to watch out for with ML is every time you do this, it is passing this data up to the Azure Cognitive Services up in Azure. So if you're doing a very large number of records, then it can take some time to process. Let's now go on to our visuals and let's look at our tweets. And for each tweet, I want to bring on my sentiment. And I can then rank that down. Let's make that text a little bigger. Great. And I want conditional formatting on score sentiment. Let's put background color. There we go. So we now have all of our tweets ranked with a score of those that are negative. Yep, it's a shame the Power BI doesn't have any backup. To those that are really positive up here. So we can then use this to group and focus our activity, to group our tweets together into these are our priority one things we need to look at. These we can get to later on. We still want to deal with everything, but it's a way of prioritizing our workload, extracting some information that helps us with our day-to-day job. You can obviously then use this in conjunction with the Q&A to then say, ask it questions such as, what is the best tweet? If I can spell tweet correctly. So it knows that tweet is a tweet from the column name. It doesn't understand what best means. So let's shrink that up and give it a bit more space. So it doesn't understand what best means, so we have to define best for it. We can click on it and define best. So we can say tweets that have a, here we go, it's given us a suggestion, high score sentiment are best. And it then gives us a preview of what that should be. What is the best tweet? And we can then save that and close, and we now get our visual, which is our best tweet. So we can combine things like the cognitive services and the AI insights with things like Q&A to really start building up some quite powerful dashboards. But to do this, we do need to have Power BI Premium. What options do we have available to us if we don't have Premium? Well, to do that, we can use Azure Cognitive Services directly rather than going through Power BI Premium. If we jump to our Azure portal, we can create a new resource called Cognitive Services. When we do that, we obviously give it our usual subscription, resource group, regions, etc., and pricing tier, which is standard. What this allows us to do is then write our own code that interfaces directly with this cognitive service from Power BI. I've already got one here available, so I'm not going to create another one, but I'll show you what it looks like. So here we have our cognitive service. We have a pricing tier. At the moment, I've got this set to be the free tier. We can expand that through to standard. What's the difference? Well, obviously one's free, but it is limited. Only 5,000 transactions every 30 days. Which is perfectly fine for testing, playing around, exploring this kind of functionality. When you then expand into the different standard tiers, you then get far more ability with, in terms of scalability, to be able to do far larger set of analysis. Either way, if we go back to Power BI, how do we use this this cognitive service? Well, let's go back to Power Query. I need to get rid of the sentiment functionality because we're going to be creating our own. There we go. I'm now going to create a new blank query and go into the advanced editor and just paste in some M code. Now this is using the endpoint that comes from my my cognitive services window. If we look at keys and endpoints, there we go, that is the endpoint. And I've got an API key here, which authenticates the use of the endpoint. And I'm packaging up the text, which is the column or the parameter of this function. And it's then wrapping it up in JSON, passing it through to the endpoint, and it's going to return me a sentiment. So this is going to give me a function, and I'm going to call this sentiment. What I can then do, I can just type some text in here to test it. I can give it some text, test it, and it'll give me a score. In this case, 0.9. So it's very close to 1. So it thinks it's a really strong positive value. If I put something else in there, it's now given me a score of 0.039. So it knows that that text is not very good. I'm just going to delete those invoked functions. But that's a useful way of just testing this to make sure it's working before we embed it into our Power Query. So now we're going to come back to our tweets dataset. We're now going to invoke a custom function. And from here, we can then call our sentiment function. I'm going to call this new column name sentiment, and we can pass through which text column we want to apply that function to. We're going to apply to the tweet. And now we get our sentiment value. Again, it puts it as a text, so we've got to change it to a decimal number. And now we get our value. So we've got pretty much exactly the same functionality, but we've now not had to pay for Power BI Premium. Now, obviously, Premium gives you so much more functionality, but if you only want Premium just for this single sentiment value, then this is a way of getting around that without having to pay that just for the one feature. Would I still recommend getting Premium? Absolutely. To save having to do this, point and click's much easier, but through not much code, you can achieve very similar results. Okay, so a quick recap of where we've been so far. We've looked at some built-in Power BI visuals, we've looked at some custom visuals, we've gone through the Azure Cognitive Services, using those either directly through the AI insights in Power BI with Power BI Premium, and we've looked at using Cognitive Services as a separate facility created through your Azure portal to avoid having to have Premium. So a few other things that we'll look at now. One is using data flows to automate some ML to get some insights into data. Now again, this goes back to needing Premium functionality. You can only put machine learning on data flows in a Premium capacity. So just bear that in mind. So all this is in Power BI Desktop. If we look at the Power BI portal, I'm not sure if any of you have played with data flows, but data flows are a Power Query table. There's no relationships of any data in there. It's purely just a Power Query that creates a table. And they're great for managing data loads and standardizing your data across multiple Power BI data sets, etc. But there's also a huge amount of machine learning functionality that you can use from data flows as well. So that'll be the next thing that we jump into and take a look at. So if we jump into our Power BI portal, here I've got a SQL Bit 2020, obviously it's a premium capacity workspace, and I'm going to create a new data flow. I'm going to define a new entity, and within this we're going to, let me just get my code. We have the same Power Query functionality, or very similar Power Query functionality than we have with Power BI Desktop. I'm going to choose a blank query here and then paste my M code in there. Now this is loading the same MPG data set that we were using a minute ago. Just need to sign into the Azure SQL DB so I can pull the data in, and here we go. And so we have the MPG and all the other columns that we saw in here. Once we've got this, I'm just going to call that MPG, and we can save and close. So this Power Query now goes and gets that table of data, prepares it using, let's call this MPG. There we go. This pulls that data down from our source, in this case an Azure SQL DB, and it brings through a table here, MPG. Now we can consume that from within Power BI if we want to, but we can also click a button over here to add a machine learning model against this this particular entity. So we've got multiple columns in here. We're going to choose the MPG as the field we're going to predict. The entity that we're going to use, the table, and we're going to predict the MPG column. So this is essentially the table, the entity, and that's the column we're going to predict within that table. And data flows works on auto ML, auto machine learning. It looks at your data and tries to work out what the best model, machine learning prediction model, can be for the data you've got. In this case, it knows it's numeric and it's linear, so it's giving us a regression model. It thinks that's the best choice for our data. It saves you having to know about all the different machine learning algorithms and models out there. So we'll accept that. And we're now going to decide which columns, which features we're going to use in our data set to actually feed into that machine learning model. And it says we're going to use all of them. It's automatically deselected acceleration because it doesn't think it has a very strong correlation with the output. So it does the key influencers style analysis on this. And it says acceleration, not that important. Now this uses a different algorithm to the one we saw in Power BI Desktop, which is why in this case it thinks acceleration is not very important. In Power BI Desktop it said it was, just different mathematical algorithms, so take it with a little pinch of salt. I'm going to include it here just for completeness. We're going to call this MPG, let's call it SQL bits MPG predictor. And we can decide how much training time we want to give this. Now this is auto ML, so what's going to happen is Power BI is going to not just train a single prediction model on your data. It's going to train lots of models, all of different algorithms, different settings, configurations, etc. And it's going to decide which one works best for you and give you that answer. The more training time you give it, the more different models it can use. So we're just going to leave it at 5 minutes and click Save and Train. So what does this do? We now have our data flow. If we go into this data flow, we now have our 3 entities. We've got the original MPG entity, which is the data, and this is historical data. This is data we know about. We know existing vehicles. We already know what their MPG is, and so we're going to use this to train our data, our prediction model. So straight away, it splits our data automatically into 2 different entities. First of all, a portion of it goes into our training data set, and then the remainder goes into our testing. So what's going to happen is that Power BI Data Flows is going to use this training data to train lots and lots and lots of models. And of those models, it'll use this testing data that it holds back to ask for a prediction of those and compare the results that it gets back with what it already knows the MPG is. And that's a way it can give it a test to see how good a model that is at predicting. And that's what it does for every single type of model. It goes through them all, works out the best one that's relevant in your data, and then you end up with a machine learning model. And here we go, here's our predictor model. And now with a little bit of video editing magic, we've fast forwarded 5 minutes and our machine learning model has been fully trained. We can see here the training status, and we can actually look at the information about this model and using the View Model Accuracy button at the bottom, it's going to give us some information about the details of the model that is created for us. And this will help us. It'll give us an idea about the quality of the predictions that it's able to create. So we can see here that it's given itself a score of 86%. 86% of the variation of the unpredictability of our MPG has now been predicted based on the other features that we've been able to provide. There's still a 14% variance that it can't explain. But that's a pretty good model. Here on the chart we see the actual predicted MPG versus the actual MPG, and we can see that it's actually a very, very good correlation. It tails off a little bit with higher MPGs where it gets a little bit skewed, but all in all it's a pretty good model. We can also look at the training details of this. And this is where we see, it actually went through 25 different models to try and find the best one for us. And we can see that the prediction quality changes quite dramatically over time. And if we look at the actual model itself, we can see it's actually using an ensemble model here. So it's actually generated 5 different models, and it thinks they're all very good in slightly different ways. And so it combines them all together into one result. So it's quite a complex system behind the scenes, but very, very easy to use. So now that we have our machine learning model, what are we going to do with it? Well, we need to use it to predict the MPG of new data for new vehicles that we don't know about yet. And how do we go about doing that? Well, if we go back into our data flow, we can then create a new entity, and this new entity is going to be our new live data. We'll again create a blank query and paste that in. And we're going to call this our new vehicle data. There we go. That's now going to validate that query. And then once we have that new entity in, we can then pass the data in that new entity through our machine learning model. Now note that we do already have the MPG column here. Ignore that. That's already there. We're going to ignore it for the prediction. We can just use it for a comparison afterwards. Okay, so now we're going to go to our machine learning model. We're going to take our predictor, we're going to apply it to our new vehicle data, and then give it an output column. And we're going to save and apply that, and that then creates 2 new output entities. The one with the actual enriched data, so that's an enhanced, enriched version of the data coming in. And also a data flow entity of explanations that helps give some insight into what's happening on that prediction. So now when we refresh this, the new vehicle data will load in from our source, it'll pass it through our model and output our enriched predictor. So now we have that. How do we consume these data flows? Well, if we go back to Power BI Desktop, then when we choose Get Data, we can just choose Power BI Data Flows. This is now going to look into our Power BI account and give us all of the different data flows that we have access to see. There we go. Let's choose this one. And we can see here there's an enriched MPG model that I created before because I haven't processed the one we've just done. And we can see all the columns there, including the regression result. Let's transform that data. As usual with most ML models, the data gets returned as text, so we change that to a decimal, close and apply, and we can then use it like any other Power BI data set. The beauty of this, though, is because it's a data flow, it's very easily shareable across different people, different data sets. So you can have one ML model resulting in one data flow, and then loads of different people in different Power BI data sets can consume that same output. So you're doing the predictions once and reusing it many times. There are some explanations in this column here. You get a more detailed explosion of that table in the explanations data flow entity. So what's actually happening here? Well, we load our data into our historical data into a data flow, and it's then split into two different groups. Around 80% goes into our training data flow, and the remaining 20% goes into our testing data flow. Then once we have that, we use those to train our model, and the AutoML algorithm comes up with the best model that can that gets the best results in the testing. Once we have that machine learning model, we can then bring in new data, new information, live data into another data flow. And that data flow can then use that prediction model to add the extra column we need to predict what that MPG value is going to be. And it outputs an enriched entity within our data flow, which we can then consume within Power BI. As well as that enriched data flow entity, it also creates an explanations entity as well, which gives us some more information about the detail as to how it came across that particular prediction. So this is AutoML. We don't really get any control over this. It's done for us by the AutoML algorithm. What if we actually want to create a machine learning model ourselves and have some influence into what it's doing and the actual decision of the algorithms being used? Well, for that we can use the Azure ML Studio. So we're just going to jump back into our Azure portal, and I've created a Machine Learning Studio Classic workspace here, and we create this in the Azure portal. And once we have this, we can then launch the Machine Learning Studio here. And once we have this, I'm going to have a look at my experiments. No, I would not like a tour, thank you very much. And I'm going to create a new experiment using the new button down the bottom. And there's a whole load of experiments here that you can preload, pre-created for you to get a feel for how it all works. We're going to start from scratch and create a blank experiment. Feeling brave here. Now on the left-hand side, you see a whole load of tasks or entities that you can drag on, including saved data sets. We can upload our data into this. So if we've got our own data, we can just upload here and then consume it. But there's also a whole lot of sample data which you can use just to get started really easily. There's actually one here which is where I got the MPG data from, and so we can just grab that, drag it on, and this is then going to be our the start of our data set. We can right-click Visualize here, and we can have a look at the source of the data. Now we don't want this model column, so let's just get rid of that. So we're going to use a select columns and data sets, join those two together, and on the right hand side we launch the column selector, and we can choose all of the values that we want to bring in, excluding the model. Okay. Now we've got our the source data that we want to build something from. We need to split our data in two. So we're going to use the split task here, and we need to say what do we want our percentage to be. Let's go 0.8, so 80% of our data to go out of the first route, and then the remaining 20% to go out of the second. And now we can train our model. So let's choose train model, and we're going to pipe in our 80% of training data here. Whilst we're here, I'm just going to bring on score there as well, just to save time later on. Now we can't train our model without first of all selecting an algorithm that we want to use. Now I know that this is better off with a regression model, so I'm just going to search for regression, and there's a whole lot of different regression models that we can call upon. I'm going to go for boosted decision tree. That'll do. So we're going to plug that in, and in our model, what column are we going to predict? We're going to predict the MPG column. Okay. And then we can pipe the output of that into our score, and then take our 20% of test data and pipe that into our score there as well. So I'm just going to run that through, and that's now going to take our data, split it in two, use 80% to train our model using a boosted decision tree regression algorithm, and then it's going to score it. Now we can look at all sorts of information about the, we can evaluate the model and look at the stats of it. We haven't got time for that today. So what I'm going to do instead is I'm just going to productionize this. Let's say we've got an algorithm, we like the output, and we just want to get it working. Well, down the bottom we've got the Setup Web Service button. I'm going to set up a predictive web service. And it's just going to simplify things down a bit. Now, because in our source input, our training input, we had to remove the model name. We're not going to do that in reality. So in the real world, we're not going to have a model name. So we'll just connect that straight into our score. We're going to run that just to make sure everything tests okay. And assuming we get some green ticks, there we go. We can then deploy a web service, again, button down the bottom. Let's give that a deploy. So what this is doing is this is compiling our experiment, it's compiling our machine learning prediction, and then hosting it as a web service in Azure for us. And we can then, from any code we like, from C#, from Python, from Excel, we can hook in to that model, send up our data like our the weight of the car, the number of cylinders, the year, etc. Send all that up to that that API, the web service, and then it'll give us our prediction back. Now we could write all the code. We don't need to because ML Studio helpfully gives us a test harness for this. So we can click the test button, and it loads up a full test harness with all the information we need. So we can then give this a test by putting in some numbers and see what comes out. So we're going to, we can ignore the MPG column because obviously that's going to be the prediction. Cylinders, let's go for 8, displacement 2000, horsepower 200, weight, sorry, that shouldn't be 2000, it should be 200. Acceleration 0 to 16, I don't know, 10, year 1970, country code 1. And we then get a prediction of 20.3 MPG. And obviously we can then change these numbers. Let's make it 1980 and see if it gets better or worse. As we would expect, we then get a higher MPG of 24 because it's a newer model. So even though it didn't take very long to train the model, it took, what, 20 seconds or so, but it still has to go through that. That's with quite a small data set. To actually query the model is very, very quick. You can do it very, very quickly indeed. So I think that tests pretty well. And this also gives us all of the source code we need to be able to actually write our own code to interface with this. So there we go, here's all the C# code, Python code and R code. You can copy this into your application and it talks you through building up the JSON structure and then firing off to the web service. But we don't want to write code, we want to use Power BI for this. So let's go back into Power BI desktop. Let's go to this one and let's stick with our MPG dataset. So how are we going to interface with our newly deployed prediction model? Well, this is where the Azure machine learning option comes in with the AI insights. So within our MPG model, I'm going to click Azure Machine Learning. That's now going to look at our Azure Machine Learning models. And here we have one which is, let's find, there we go, that one there will do. And we can then say, right, let's hook in all of our columns, okay, and it's then going to add an additional column onto the end for us. Now this adds an entire record, so we just need to drill through into this and get rid of all the other columns. All we want is the actual scored label mean. We can get a standard deviation as well to give us some kind of understanding of the error there, but let's just go with that scored label mean. So we can see here this is now the predicted value, change that to a decimal again. That's the predicted MPG of this vehicle. And you can see how quick that was. So every time we refresh this data set, we bring in new data from our source, it'll pass it through that algorithm and give us the response back again. So that was very easy. And we can also call that same ML system from a data flow as well, if you want to. So using that ML Studio, there's a reasonable amount of flexibility in there, and it does give you the option to be able to edit, to change the parameters of what you're doing, but it's still not the same as actually writing your own code. And Power BI does give you the option to write your own Python or R code if you want to as well. So to do this, I'm just going to load up an existing Power BI document that I've got. And importantly, I've already got Python installed on this PC. If I was using R, I would have to have that installed as well. And so what we can do with this now is we're going to do the same sentiment analysis in our tweets. So I'm going to go to, and so we've got this column here, the sentiment that this code creates. If we go back into Power Query, we can see how this works. When we get to this point, if we, where are we here, on the Transform tab, we have Run R script and Run Python script. And clicking that injects a step into our Power Query where we can just copy and paste or write our Python code. So this is the Python script that we have here. We can click on the cog next to it to see the details of it. And this is just a very, very simple 4-line Python bit of code. Let's zoom into that. And we have, critically, we're importing pandas. Now, the set of data, or the data set that comes from the previous Power Query step, is presented to Python as a pandas data frame. So once we import the pandas library, we can then interface with that data frame and access the columns that come from Power Query. Here I'm importing a sentiment intensity analyzer, which is the from the NLTK sentiment Vader library. And once we have those two imported, we can then add a new column called sentiment to our data set. Data set's the name, how we refer to the incoming data set from the previous Power Query line. And so we're going to add a new column called sentiments, and we're basing it on the tweet column and then applying our sentiment functionality to it. By all means, copy and paste that code in your own code. Note this uses your local Python installation and library. So you have to configure Power BI Desktop as to which Python library, Python installation you want to use in order for this to work. And the same with R. So once we've done that, we then get the results. Now it actually returns the whole thing as one table, so we have to then drill back through it, or drill into it rather, in order to get access to the underlying data, and then we end up with our sentiment column. So is that better or worse than using the cognitive services or calling an Azure ML script, etc.? It entirely depends. Obviously it doesn't need to have Power BI Premium, which is a benefit. However, when you deploy this up to powerbi.com, it's not able to run the Python code within powerbi.com service. You have to have the personal Power BI gateway installed, and it has to be the personal gateway, not the enterprise gateway. And that has to be a gateway down to a machine that has the Python installation set up on it. And so what Power BI does is it takes the data sets, Power Query pulls the data in, passes it down to your personal gateway, it runs the Python code, and then sends you the results back. So you need to consider the potential performance implications of that with large data sets. But for most data sets, there's no problem at all with doing that. Is that better or worse? Well, it gives you more flexibility in the Python code, but it takes more coding. obviously with cognitive services and the Azure ML Studio, it's just a much easier interface. It's all drag and drop and point and click without actually any coding to do. Just to go over some details of Python, if you will want to have a play with that, you can install Python from python.org. You need to install the personal gateway on the machine with Python installed, and then interface everything with the pandas data frame. To install the libraries that I just used, we're using pandas, NLTK, and matplotlib, and then we're downloading the Veda lexicon, and then the 4 lines at the end are the code that I used to do the sentiment analysis. So all of that's great for doing data transformation, but if we're embedding Python or R inside our Power BI workbook, can we use that for enhanced visualizations as well? And it turns out, yes, we can. If we go back to our Power BI workbook, we have the R and Python visuals up here in the visualization pane. And it turns out all we have to do to enable those is drag them onto our canvas. We need to tell the visual which of our fields we want to give access. So here I'm going to look at the MPG and the weight. And down at the bottom we have our Python script. I'm going to paste in my code, and all I'm doing here is importing matplotlib, the pyplot function, and I'm setting the style of my visual to set some grid functionality. I'm saying I want a scatter chart with weights against MPG, and then showing the plot. And if I click the run script, then that shows me a scatter plot on my chart. Now this is a visual obviously created by Python, so you're not limited by any Power BI visuals. This has the complete power of all of the Python or R visualization libraries, which means you can do some phenomenally complex visualizations with this. What are the pros and cons of this? Well, the pros are obviously it's very, very flexible, but also you have to be aware of some limitations. So let's say I create another visual here with year and MPG. We want the MPG on values. There we go. And if I interact with this visual, we can see that it is cross-filtering across to our Python visual. However, the same does not work the other way around. If we click on our Python visuals, nothing happens. So do be aware of the limited interaction between your Python and R visuals going out to your other visuals. But as long as you're okay with that, then it does provide a very powerful way of visualizing far more complex data than you can otherwise. Right, so where does that leave us? Let's go back to our original agenda. We've looked through 6 different ways of combining machine learning functionality into Power BI, and they all provide a slightly different experience on the spectrum of complexity or coding required against the power and the control that you have available to you. Obviously the built-in Power BI visuals, incredibly easy, they're getting better all the time, but they don't really give you much flexibility. Then some custom visuals do, and then we go to the cognitive services, which give you quite a lot of ability to transform your data if they're aligned with the cognitive services that are available. If they're not, then you can go to Dataflow for analyzing your data with the automated ML, or if you actually want to do more complex work, we've got the Azure ML Studio option, hand-rolling your own machine learning model and then interfacing it from Power BI. And then at the very top end of the spectrum, you've got Python. I say Python or R, it's entirely your choice. They're both supported. And that's getting proper hands-on with the code, embedding Python into your actual Power BI data set. So I hope that's given you some insight into the different options available to you with using machine learning into Power BI. There are, of course, other options we haven't had time to talk about, things like Databricks, But these are the core, the first starting points that are going to be most relevant to most people. So hopefully it's given you some direction on how you can get started using this. If you have any questions on any of this that I haven't been able to answer in the chat window during the session, then please do drop me an email, drop me a tweet on any of my details on the screen at the moment. I'll be more than happy to answer any questions after the session. And that also goes for any Microsoft BI type solutions, type questions. We need to offer a very big thank you to Microsoft for supporting Data Platform Geeks and SQL Server Geeks. Without Microsoft's support, not only in the technology, but also supporting these events, then they really wouldn't happen. So thank you, Microsoft. And of course, a big thank you to you for joining the session. There are 3 ways you can win prizes. Please do post selfies on social media using the DPS 2020 hashtag. More prizes for session and conference feedback. As an organizer and speakers, people do really value the feedback you provide, and that does help go to improving the sessions in future. And of course, go and see sponsors and exhibits. Very big thank you for joining the session, and have a great rest of the conference.